All right, let's talk about one of the most important parts of your car that you probably never think about, the starter motor. Seriously, this little guy is the powerhouse behind the powerhouse, the absolute unsung hero that makes every single drive you take even possible.
I mean, really think about it for a second. You turn a key, you push a button, and this massive 2-ton machine just roars to life. It feels like magic, doesn't it? But in those first couple of seconds, there's this incredible, perfectly timed mechanical ballet going on, and it all kicks off with this one little device.
And see, that's the whole challenge right there. An internal combustion engine is amazing. It can sustain itself once it's running. But getting it to that point, that's the problem. It needs a huge external kick in the pants to start that whole cycle of intake, compression, power, and exhaust. On its own, it's basically just a big, heavy paperweight.
You know, it's kind of like trying to push one of those giant, heavy merry-go-rounds at a playground. That first push from a dead stop takes a massive amount of effort, right? But once it's spinning, it's way easier to keep it going. Well, your engine is that stationary merry-go-round. Without a starter, it's going nowhere. But with the starter, it gets that critical first shove, all from this surprisingly small electric motor.
So how exactly does the engine get that big push? Let's go ahead and formally meet the solution to this whole problem, the little component that delivers that all-important first move.
Okay, so the starter motor is a total specialist. Its entire job, its whole reason for being, is to perform one single, incredibly intense task: crank the engine's crankshaft just enough for the engine to take over and run by itself. It's all about delivering a short, sharp, and absolutely massive burst of force.
Now, to really understand how this small motor pulls off such a huge job, we've got to look inside. So let's pop the hood, so to speak, and break down the tools it uses to get the work done.
So here are the key players in the starter assembly. Each one has a totally critical role in this split-second sequence. We're going to focus on the two parts that really manage the brains and the brawn of the whole operation: the solenoid and the pinion gear.
The solenoid is just brilliant because it does two things at the exact same time. First, it's like a superpowered light switch. It closes a circuit that lets a massive flood of electricity flow to the motor. And while it's doing that, its electromagnet physically shoves a gear forward. It's basically the mission director for the whole startup sequence.
And this little guy is what the solenoid is pushing. The pinion gear is the physical link, the handshake between the starter and the engine. It's this small, super tough gear that slides out, meshes its teeth with the giant flywheel on the engine, and that's how the power gets transferred.
Now, let's talk about the raw power we're dealing with here. To get a cold engine turning, fighting against all that friction and compression, a starter motor can pull up to 400 amps from the battery. To give you some perspective, that's more than 20 times the power your microwave oven uses. It's a ridiculously huge surge of electricity, which is exactly why it only needs to happen for a second or two.
Okay, so let's put it all together in real time. You turn the key, a little bit of current zips to the solenoid. Bam! The solenoid pushes the pinion gear into the flywheel and, at the same instant, slams the main power switch shut. A tidal wave of current hits the starter motor, making it spin like crazy. That spin turns the pinion turns the flywheel, and the flywheel cranks the engine. The engine fires up, you let go of the key, and the whole system retracts. All of that, mission complete, in less than 2 seconds. Wow!
Of course, the only time we really notice the starter is when it doesn't do its job, right? When you turn the key and nothing. So what happens when our hero stumbles? Well, the sounds your car makes can actually tell you a whole lot.
This is where you get to be a car detective. If you hear one single loud click, that's usually the solenoid firing, but the motor itself isn't turning. Hear a high-pitched whirring or spinning noise. Well, that means the starter motor is spinning just fine, but the pinion gear isn't actually connecting with the engine. And if it's a slow, sluggish rrr sound, the motor is probably struggling from a weak battery. By just listening, you can often figure out what's wrong before you even open the hood. And all of this brings us right back to the main point. For a component that performs such a violent, high-power job every single time you start your car, the starter motor is truly 100% the unsung hero of your vehicle.
When you boil it all down, it comes back to this fundamental transformation of energy. Every single drive you take begins with the starter motor taking electrical energy from your battery and turning it into the raw mechanical force needed to spin an entire engine into existence.
I mean, it's just a masterpiece of engineering. It's built for incredible torque and unbelievable reliability. It does its brutal job flawlessly, day in and out, for years, just hiding down there in the engine bay, waiting for that one moment you turn the key.
So, the next time you get in your car and turn the key, just take a half second to appreciate that incredible burst of power. It kind of makes you wonder, doesn't it? What other amazing, vital little machines are all around us, hiding in plain sight, just doing their job every single day?